Question number 61. In case of bromination to benzene in the presence of FeBr3, the electrophile is. In benzene, you are just going to do the process of bromination. That is electrophilic substitution reaction, and in that case we use FeBr3. Actually, this FeBr3 when combines with bromine, this is Br2, we know that, and there is the formation of FeBr4 negative, that's a nucleophile. Along with that, electrophile Br positive is generated. It means the desired electrophile is Br positive is generated. It means the desired electrophile is Br positive. So we'll choose option 3 as the correct option. After that, question number 62 I have. Question number 62. The gas leaked in Bhopal gas tragedy was. It was an hazardous gas that causes a lot of casualties in Bhopal, and that gas was commonly known as MIC. This MIC stands for methyl isocyanate. And what's the structure? Its structure is methyl group and NCO, that is isocyanate, and this was the main cause of this disaster. That is option 4. That becomes correct in this case. Question number 63. 3.011 into 10 to the power 23 molecules of sugar are present in 200 ml of its solution. The molarity of the solution is. In this case, if you just want to find out the molarity, you need the number of moles, first thing. Then you need the volume, that should be in liter. Volume is correctly given here, that is 200 ml of the solution. So volume of the solution you have, you will change it in liter, but you need the number of moles. The correct hint, it's given here, that you have this much number of molecules of sugar. With the help of this, we can find out the number of moles of sugar. So moles of sugar that we are assuming as N are equal to the given moles divided by Avogadro number, that's 6.022 into 10 raised to the power 23. The simple question it is. Moles we will find here, those are 0.5 moles. Now what would be the molarity? Simply the molarity would becomes moles of the solute present in the solution divided by the total volume occupied by the solution. So that is 200 divided by 1000. So this 1000 will come here. And this becomes 5. And the molarity would becomes 2.5 m. Where this 2.5 m is given, it is given here in option 3. So just choose option 3 as your correct option. After this, question number 64 we have. The orbital angular momentum of an electron which is present in p orbital is. Orbital angular momentum. Orbital angular momentum, that is equal to root L into L plus 1 H cross. So here, if we talk about this, in this case, orbital angular momentum of an electron which is present in p orbital. If it is given that p orbital is there, for this orbital, the value of L is 1. If the value of L you have, you can easily find out the orbital angular momentum in this case. That would be equal to root 1 plus 1 H cross in this way. So that would be equal to root 2 H cross. Where it's given? It's given here in option 3. So choose option 3 as your correct answer to get the marks for this question. After that, question number 65. What is the maximum number of orbitals that can be associated with the following quantum numbers? We have the quantum numbers. N is equals to 4, L is 1 and Ml. That is magnetic quantum number, that's 0. If I talk about N is 4, it means we are talking about fourth shell. If L is 1, it means it is 4p orbital. In case of 4p orbital, there would be the three values of L. Those are -1, 0 and +1. And if we are talking about this value of magnetic quantum number, for which this value is 0, then in this case the orbital associated with this would be 1 only, in which 2 electrons can accommodate. So simply in this case, one orbital can be there that would be associated with the given set of quantum number, and that's why option 1 becomes the correct option. After that,